Now in today's video we will study about the preparation of ethers. The first method of preparation is by dehydration of alcohol. Now when alcohol is heated at 100 degrees centigrade, it forms ethyl hydrogen sulfate, and if this temperature increases at 170 degrees centigrade, it forms ether, and the temperature is at 170 degrees centigrade, it forms ethene. The first ethyl alcohol when ethyl alcohol is heated in the presence of concentrated H2SO4, it forms C2H5O, C2H5. This is diethyl ether, and the temperature here is 170 degree centigrade. Now mechanism of this reaction: first step is protonation of alcohol. First step, protonation of alcohol. Ethyl alcohol on accepting one proton, it forms protonated alcohol. Protonated alcohol. In the second step, the protonated alcohol reacts with second molecule of ethyl alcohol. It forms diethyl oxonium ion. This electron pair, so it forms third step is deprotonation. Third step, deprotonation, means removal of the proton from the diethyl oxonium ion to form dipropionate ethyl ether plus H plus. Now next is, now this method is suitable for the preparation of ether having alkyl group. The alkyl group should be unhindered and the temperature should be low for the preparation of ether. If the alkyl group is secondary and tertiary, it will undergo elimination reaction, that is, instead of ether it will form alkene, that is, it will sometimes question is asked कि why secondary and tertiary alcohol will lead to the formation of alkene, not ether. So here answer is, that is, elimination competes substitution. As a result, alkene is formed. Next is Williamson synthesis. Now, Williamson synthesis is the method of preparation of ether when alcohol reacts, sodium alkoxide reacts with alkyl halide, it forms ether. Now, alkoxide is formed when alcohol reacts with sodium. Now, Williamson synthesis. So, when alkyl halide reacts with in the presence of dry ether, it forms ROR plus NaX. Now again, the ether containing substituted alkyl group, that is secondary or tertiary, may also be prepared by this method, and it follows SN2 mechanism. It follows SN2 mechanism. Now the important point we should keep in mind is that the alkyl halide the alkoxide should have the tertiary alkyl halide and the alkyl halide should have primary group. This is secondary group, tertiary group, and this is primary group. Now when this reaction takes place, ether will be formed. But if primary alkoxide and tertiary halide reacts, then it forms alkene. It forms isobutylene. So again plus CH3OH. So better results are obtained if the alkyl halide is primary. Next is, now the alkoxide ion behaves both as nucleophile as well as strong base. That is why isobutylene is formed. Question is asked why, if tertiary alkyl halide is taken, isobutylene, that is alkene, is formed, because alkoxide behaves both as a nucleophile as well as strong base. Next, by this method we can also prepare aryl ethers. Now phenol reacts with sodium or sodium hydroxide. It forms sodium phenoxide. Now this sodium phenoxide reacts with alkyl halide. It forms alkyl aryl ether. Next is physical properties of ether. Physical properties now the ROR, this RO bond is polar, therefore the ether has net dipole moment. RO bond is polar, therefore it has net dipole moment. Number 2, these ethers, due to its weak polarity, they combine together by weak dipole interaction. Dipole interaction. Now if we compare the boiling point of ether with alkane, alkane will have higher boiling point. Ether will have higher boiling point than alkane because of dipole interaction of comparable molecular mass. comparable molecular mass. Next, if we compare the boiling point with alcohol, so alcohol has higher boiling point than ether because alcohol form hydrogen bonding, which is stronger as compared to dipole interaction. Thirdly, you can also compare with alkene, but you should keep in mind that is the carbon atom in both the compounds should be same, comparable molecular mass. Now next is solubility. Now ether can form hydrogen bonding with water molecule. Ether can form hydrogen bonding with water molecule, therefore it is miscible in water. Ether is highly volatile. It can escape out within an hour if you keep a bottle of 500 ml. Ether is replaced by chloroform nowadays as an anesthetic agent. Now solubility. Soluble in water. Ethers are soluble in water because of the formation of hydrogen bonding. Because of hydrogen bonding, ROR. So it can form hydrogen bonding. Next comes that is chemical reaction. Now chemical reaction, so first we will study the reaction due to the cleavage of CO bond. Now when ether reacts with hydrogen halide, it forms one molecule of alcohol, and when ether reacts with hydrogen halide, it forms one molecule of alcohol and one molecule of alkyl halide. But if excess of hydrogen halide is taken, both the molecules of alkyl halide is formed. Similarly, the aryl alkyl ether reacts with HX, it forms phenol, and Rx. So always ether with two different alkyl groups are also cleaved in the same manner. In the case of aryl alkyl halide, always here phenol is formed because of the more stable aryl oxygen bond. Now the order of reactivity of alkyl halide is hydrogen iodide is greater than HBr is greater than HCl, and it is almost for this series is almost same for every compound. The reactivity of HI is always greater than HBr and then HCl. Next is now in the ether group, if one of the alkyl groups is tertiary and one is the primary, then always tertiary alkyl halide is formed. If one of the alkyl group is tertiary and one is primary, then always the alkyl halide will be formed with tertiary alkyl halide and alcohol will be formed with primary alcohol, and this is because the tertiary carbocation is more stable and follows SN1 mechanism. It is because the tertiary carbocation formed is more stable and it follows SN1 reaction. Now in the case of anisole, now anisole is the common name for phenyl alkyl ether. Now in the case of anisole, methyl phenyl oxonium ion is formed by protonation of ether, and the bond between CH3O is weaker than the bond between C6H5 because the carbon of phenyl group is sp2 hybridized and therefore it acquires double bond character. So here phenol is formed. Earlier also I told you, in the case of the preparation also I told you, phenol plus alkyl halide. So in the case of this aryl methyl ether, this oxygen after accepting one proton it forms oxonium ion. So this CO bond it acquires double bond character, therefore it always forms phenol and alkyl, that is methyl iodide. Next chemical reaction is electrophilic substitution reaction. Electrophilic substitution Now, electrophilic substitution reaction. The ether group is ortho-para directing. Ether is ortho-para directing, just like alkyl halide let me rub it and draw it again. And we will draw the resonating structure of electron pair will move here and the bond will move. So, just like alcohol and alkyl halide, not aryl halide, the electron density is maximum at ortho and para position. So, the incoming group will go to ortho, and again this electron pair will move and this bond will move. It will form again this electron pair will move and this bond will move. It will form so in the 3 resonating structure you can see that the electron density is maximum at ortho and para position. So the incoming group will go to at ortho and para position. So now under it, first we will study halogenation. Now aryl alkyl ether, that is phenyl methyl ether, is commonly known as phenyl methyl ether, is called as anisole. Now this reacts with bromine in the presence of ethanoic acid. It forms orthobromoanisole and para bromoanisole. Next is reaction with alkyl halide in the presence of anhydrous AlCl3. Now, when it reacts with when ether reacts with alkyl halide in the presence of CH3Cl in the presence of anhydrous AlCl3, then it forms methoxytoluene. Methoxytoluene and 2-methoxytoluene and 4-methoxytoluene. If in place of alkyl halide we take acetyl halide, then acetophenones are formed. And collectively they are called as Friedel-Crafts reaction. Collectively they are called as Friedel-Crafts when phenyl methyl ether reacts with acid chlorides. It is also called acetyl chloride in the presence of anhydrous AlCl3. It forms 2-methoxyacetophenone and 4-methoxyacetophenone. Two methoxyacetophenone and 4-methoxyacetophenone. Next is nitration. Now the previous reaction and this reaction both comes under Friedel-Crafts reaction. Now nitration, that is when ether reacts with concentrated nitric acid and concentrated H2SO4. It forms 2-nitro-anisole and 2-nitro-anisole and 4-nitro 2-nitro-anisole and 4-nitro-anisole. Now, in this session or in this video, we have studied about ether, its method of preparation, physical and chemical properties of ether.